And we're going to have a whole bunch of potassiums up here. And down here we have a bunch of sodiums. A bunch of sodiums. Does that make sense? Okay. So our first thing that's going to happen is we're going to jump into depolarization. So right now we're at negative 70 millivolts, right? And it's basically because the inside of the cell is so negative that any potassiums that might be floating around out here, they're going to come in through this potassium gate and just jump right in. Is that okay? So I should really write the negative 70 up here because we're really talking about up here. Kind of like what Samantha was talking about. So our next thing that's going to happen is we're going to start our next step, which is depolarization. Depolarization is where this is open. Oh, sorry, this should have been closed, but now it's open. So that's open. This is going to be closed. And if this is open and this is so negative, what's going to happen? Yeah, the sodiums are going to go in. Awesome. So our sodiums are now going in. And I know that I'm being lazy and your kit is sort of being lazy, but imagine thousands of these sodiums rushing in and thousands of these potassiums running out. That's going to be more of a charge than 3 or 4 moving in and out. Does that make sense? Okay, so this is going to be our depolarization. And because we have so many potassiums and sodiums, what's the inside of the cell going to be right now?
Super positive.
So it's going to be super positive, right? So it's going to be positive 30 millivolts.
Yep.
Okay?
Yep.
Cool. Potassium, is it super happy right now?
No.
Nope. So what's going to happen is this gate is going to open. Open. This gate, is it still open?
No.
Nope.
Close.
It's going to close too. Close. And now what's going to happen is all the potassiums are going to run out. And they're going to be gone from this side. Oops, got it. Okay, something like that. So now the inside of the cell, is it still positive 30?
No.
No. What ends up happening is too many potassiums leave. So we actually are over here, we're starting to make this dip. And what happens is we get to minus 90. So really I should have put the number down here just so you could see that it was at that point, but I was trying to put it like right here. I'm hoping you think it's right here, not like somewhere around here. But we're at minus 90 right now. So we need to get back to normal because we might have to move the muscle again. So what we're going to do is we're going to close our potassium pump. Potassium pump, close. And what's going to happen is we're going to activate our sodium potassium pump. And there's a whole process that has this open. I'm going to skip it, but basically it requires ATP to make this thing spin. And what's going to happen is for every 3 sodiums it pushes out, it's going to bring in 2 potassiums. So every time this spins, it's going to bring 2 potassiums in and kick 3 sodiums out. So it's going to keep doing this and doing this until eventually we get back to minus 70. And then at minus 70, what will happen is the sodiums will be on this side. There might be some potassium still on this side, but we'll open this door a little bit. So if there are some, they can still sort of leak in. The sodiums will be gone. And then we're back to our normal charge again, so which is going to be minus 70. So we can have another action potential happen again and again and again. So think about anything you repeat over and over again, like talking. That's going to move your vocal cords, and that all requires action potentials, and it happens so fast that you can do that. Going for a run, doing whatever is going to require this to happen again and again and again in milliseconds, so that's what's going on. Cool. I know that's a lot. I think I almost want to curl into a ball because I've explained it so many times. So once you're done, you're going to explain it to your neighbor, or if you're done because your neighbor is as zapped as you, I'll bring the kits again, and that'll be the first thing we do on Thursday.